Hello and welcome back to our class, and today we are solving vectors on collinearity. So given the points P, -6, -3, Q, -2, -1 and R 6, 3, express vector PQ and QR as column vectors, and hence show that the points PQ are collinear. Now there are certain things that you're supposed to know, that points are said to be collinear if vector formed from the points are parallel. That means they can be expressed as a scalar multiple of the other. B, they must have a common point. So when you're given the 3 points, you're supposed to form 2 vectors from them. Then we see what happens next. So what we start, we've been told to express vector PQ and QR as column vectors. So we're going to start with PQ. So PQ, you take Q minus P. Now you express this point Q as a column vector, -2, -1, minus P expressed in, you convert it from coordinate to column vector. It can be written as -6, -3, then -2 minus -6, that will give you 4. -1 minus -3, that will give you 2. That is PQ. Then you go to QR. QR, you take R minus Q. So R in terms of column vector, it is written as 6, 3, minus Q in column vector is written as -2, 1. This one gives you 8, 4. 6 minus -2 is 8. 3 minus -1, it is 4. 3 plus 1 is 4. So we have expressed those points, formed 2 vectors from those 3 points, vector PQ and QR. Then I can come and say PQ is equals to KQR. So what is PQ? PQ is 4, 2 is equals to, K is what you don't know, 8, 4. So we need to get what is K. So you can take the upper values and say 4 will be equals to 8K. So to get K, divide both sides by 8. So our K will be 1/2. Even if you take the lower values, like for example 2 is equals to 4K, you will still get K is equals to 1/2. Alternatively, you can say QR is equals to KPQ. So if you take QR, this one will be 8, 4 is equals to K, 4, 2. So getting the value of K, you'll say 8 is equals to 4K. So divide both sides by 4, K will be equals to 2. The same happens if you take the lower values, you'll still get K is equals to 2. So meaning PQ can be equals to, when K now is 1/2, when we express it this way, PQ will be equals to 1/2 QR, or QR will be equals to 2 PQ. So meaning you can either choose this one or this one. So we have expressed PQ or QR as a scalar multiple of the other. So when you do this now, you come and say hence PQ is parallel to QR. So you have shown, when you do this or this one, you have shown that PQ or QR is a scalar multiple of the other. Then now you need to write it this way to show that now they are parallel. Then we have said that you have to do 2 things. One is that you must express as a scalar multiple of the other. 2, you must show there is a common point between them. So if you check between those two vectors, we have a common point, which is Q. So you can say Q is the common point. Q is a common point. And you have shown that those 3 points are collinear. You can try this as a follow-up. So you are given the points A, B, and C. Express A, B, and C, AC as a column vectors, and hence show that the points A, B, and C are collinear.